than the one that we were standing next to. In other words, this has got to put out more water than this. It's not like, it's kind of similar in a sense to a gated pipe, but a gated pipe, we want the same amount of water coming out every hole, every gate. This, we want different amounts, okay? So we can't use that factor that we use for gated pipe. It's a different factor. And in the middle of page, better look at the one you have, the page 3, we have the friction adjustment factor. And for 270 outlets, that friction adjustment factor is 0.55. For 73 outlets, it's 0.555. And for 40 outlets, it's 0.56. So in other words, it's always about 0.555. That's the one we're going to use. Okay? Now I didn't count for how many nozzles he had, but for a 1,320-foot pivot, we often have like 120 nozzles, something like that. You know, but more than 40 and more than 73, we're going to use 0.55. Okay? So now we're going to do the next question, and we'll do it together. A 1,320-foot center pivot epoxy-coated steel lateral. So now I'm telling you, this is a center pivot lateral, okay? This is not just a straight pipe. This is a center pivot lateral. It's got drops on it, okay? And it's got, we've got a diameter, we've got a flow. What's the change in pressure along the lateral? What is the change in pressure along that lateral? So let's do this one together. So I've got 1,320 feet. I'll say this is my pivot point right there. This is 1,320. All right, and I've got drops all the way along. Water's coming out. What's the flow rate at the end?
900.
Center pivot, what's the flow rate at the end?
Very, very end?
At the very, very end, of that lateral.
The last nozzle.
It's not
zero.
It's zero. There's no water coming out the end, right? We've got a plug to maintain our pressure, right? But there's no water coming out the end, right? So if I put in my Q in is 900 gallons per minute, my Q out of the lateral itself, I'm not talking about the last nozzle, the lateral itself is zero. That means when I sum up the Qs, the flow rates out of all of these nozzles, I have to get 900 gallons per minute, right? So what is the friction loss here? All right, and one more thing, let's see, 6 5/8 inch, 1,320, epoxy coated steel lateral. What's the change in pressure? All right, what is step 1? Step 1 is, let's figure out, assuming this is not a center pivot lateral, it's just a straight pipe, what's the friction loss through it? Well, I've got all the data I need. In fact, I haven't even changed this. I think I can probably use my 3.73, right? Was it 3.73? Okay, 3.73, what is that? 3.73, need units, feet per 100 feet of friction loss, all right? For this, now this is step 1, just pretend it's a straight pipe with no nozzles, okay? And now, how many 100-foot sections do I have?
13.2.
13.2, so I multiply this by 13.2, and I should get something around 49.3?
Yeah. Yeah.
I'm sorry,
49.2.
Thank you. 49.2 feet of friction loss. Step 1. But this is not a straight pipe. It is a center pivot lateral. I've got less water flowing through this section than I do through this section. Would you expect the friction loss to be bigger or smaller since I'm taking water out as I go along? Hopefully you would see that the friction loss is going to be smaller because there's not much water coming out here relative to what's flowing through the pipe here. Okay? So what is my friction adjustment factor? It's 0.555. So I multiply this by 0.555, okay? And if I want, I can convert that to, I want to make sure I'm on the right page here. Well, it's just, I got 27.3.
Yes.
You agree with me? So that's 27.3 feet of friction loss. And I hope, now, if I ask you how many pounds this is, you'll get an answer around 10 pounds, maybe what, probably 11?
11.8?
11.8 pounds, okay, PSI, friction loss, between here and here. Now, what effect does this have when we're designing, okay, and I know we're not really designing, we're checking someone's design, but if we're looking to design a center pivot lateral, and I've got a 10 or 11.8 pressure difference between here and here, is that going to affect my flow rates out of the nozzles? Yeah,
Yes.
right? I mean, because if I start with 20 here, I'm going to have something around 9 here. And what do we know about those nozzles that you have in front of me? That the flow rate is dependent on the pressure. More pressure, more flow rate. All right, so the same exact nozzle here and here, which is not the way we do it with the center pivots, but if it was, this nozzle and this nozzle, this one would be producing more water. Okay? So what is it, which one do we actually want to be producing more water? This one out here. So what am I going to do? Are my nozzles going to get bigger or smaller as they go from the pivot point to the end? They're going to get bigger, all right? They're going to get bigger for two reasons, all right? Now this is assuming I don't have pressure regulators, but not only do I need more water, but I have less pressure, assuming a flat field. If I have less pressure, I'm going to have a bigger nozzle. So kind of working, that friction loss is working against us. I'm going to have to overcome, number one, that I need more water because out of this nozzle, just as nature center pivots, but I also need to know that, hey, wait a second, I'm going to have less pressure, and if I have less pressure, I'm going to have a bigger nozzle to get that Q, whatever my goal of my flow rate out of the nozzle is. Okay? That make sense?
Yes.
Okay. So let's look at the next one, and I'll let you do this one. The same question. Oh, actually, we're not ready to do the last one. The next one. Sorry. Jumping ahead a little bit. Okay. Yeah.
You may want to point out that if it was a lateral, it would be 0.555.
Right. So if it's a linear move, okay, linear moves are very similar to, say, a wheel line, or similar to a solid set. All right. So let's say, just for example, I'm take away this part of it and say this is just a linear move, okay, that it's not circulating. What do I know about the flow rate here of that nozzle and the flow rate there of that nozzle?
Same.
We want it to be the same, right?
Yeah.
And if I don't account for friction, it's not going to be the same, right? If I have the same nozzle throughout here, okay, it's not going to be the same. So what are my options for a linear move now, where I want this one? Now, just to pick a number, I want 2 gallons per minute here coming out of that nozzle and 2 gallons per minute here. What are my options? Yeah, first of all, I can have a pressure regulator and make sure that the nozzle sees the same pressure, and that's really the classic way to do it, okay? The other way I could, if I need 2 gallons per minute out of this one, I could make this a little bit bigger, okay? But it doesn't have to be, we don't, in that case, we would use that friction factor from keep on thinking multiple outlet pipes, gated pipes. Okay, we could use that to do this calculation. But the point is, it's going to be, we want the same amount of water to come out. And so the trick is use pressure regulators or make sure you have very little friction loss, okay? Is that possible to have very little friction loss here? Yeah, I could just have a larger diameter pipe, right? I mean, here I lost 27.3 feet, or 11.8 psi. But if I went to that 8-inch, I would have less pressure loss, all right? And that way I could keep the same size nozzle all the way along and have the same flow rate. But Lewis is, I mean, in practical terms, we just put pressure regulators on it and we're done. Yeah.
Is there any way to take a wheel line and economize that? Is there any way to take a wheel line and economize it, get rid of some of the wheel cost?
Claire, you're from, Claire grew up and worked in Utah. That's the capital of wheel lines. What did they do with wheel lines, Claire?
I say, is there any way to economize a wheel line? Could we take the same concept and economize a wheel line? Because we burn that power line basically.
Yeah, you can economize it. You can use dual pipe sizes.
Bigger the pipe.
Yeah.
Pressure regulator.
Pressure regulators, they generally don't use them because they have to get it right some level. So